Hello. In this session we are going to build a program using ZIO for a restaurant called Il Forno, which performs requests to prepare a pizza using the ingredients in the kitchen. In case if there is not enough ingredients, this program will fail with unavailable ingredients. For a helper function, it would be something like this. To prepare a pizza, it needs a request which contains the pizza type, and each pizza type has the ingredients that needs. And the ingredients. The ingredients would be the current available ingredients that we have, so we can check if we can return, if we can prepare this pizza. So in case of success, we are going to update these ingredients, and in case of failure, this will, if there is not enough ingredients to prepare the requested pizza, we will return io.fail unavailable ingredients. Now, let's start with the how to make, how could we perform the requests and how could we preserve the state of the available ingredients. We need to use different data types for that. For the requests, we want to serve the customers who came first. In ZIO there is a data type called queue, which is a FIFO queue, and for the state we can use ZIO-ref, which will preserve the state and we can update it. So it would be like this: class system, and it has requests of type queue of request, and the state would be like available ingredients of it is a ref of map of ingredient int, and here the int is the how many ingredients that we have. Nice. Now let's think, how could we add requests to the system? We can implement a function called send request that takes a request, and we will not get any result from it. It will never fail. Just add the request to the queue. So we will call requests.offer, and offer is a function in the queue that will add an element, a new element to the queue. This will return a boolean, and this boolean depends to the type of the queue that we are going to use. I will explain this later, and because we will ignore the result, so we can call .unit. Now let's implement the function that will perform these requests. Because our programs is of type IO, so if we will not have any input, we can do val. Val and def have the same meaning in ZIO programs. Okay, so let's say handle request, and we will see what we would return, but for now this program might fail with unavailable ingredient or succeed with a unit. It will just perform requests, and in case of error it will return unavailable ingredients. So we can call for we can first of all have the request take the oldest request from the queue, which, so dot take will give us the oldest element in the queue. Then we need to call prepare pizza, but we need the current ingredients, and we can get it out from the ref using maybe old state. We can call available ingredients.get. This is the current state. Maybe current state would be better name. And this, we need to prepare pizza here. Let's call system.prepare pizza of the request and the current state. This will give us back the new state, because it will update the current state in case of success. And then we need to update the state, and we will set the new state. So directly we can call available ingredients.set new state. And that's it. So here we performed just only one request, the oldest one, and we made sure if we can prepare the pizza for that request, and we changed the current state. But the system will perform many requests, so this we need to schedule this action. We can call repeat. In case of success, we will repeat this action, and let's say we want to perform the request and then wait 15 seconds and then perform the next request and wait 15 seconds, and this could be done using schedule.spaced 15 seconds. So let's import ZIO.duration, and also because this will repeat this action continuously, but the restaurant will not work forever. It needs to, like, maybe 8 hours. So we want to stop this action after 8 hours. We can call end schedule dot duration 8 hours, and this operator will this and will returns a new schedule that continues only as long as both schedules continue. So the space will be always will continue forever, but this will continue during the 8 hours since we started the system, and then it will stop. Once this will be invalid, the whole thing will stop, and the action, so this action will be performed every 15 seconds during the 8 hours. This is what we want. But now let's think about something. Imagine if there is someone who ordered a pizza. For example, someone ordered pizza margherita and there was no more tomatoes. This program handle request will fail with unavailable ingredients. What will happen for the next customer who ordered pizza 4 fromage? This request will not be performed anymore because it will not be repeated, because the previous request was failed, and the repeat will repeat only the successful requests. And imagine the customer will, like, the request will affect the next requests, and this doesn't sound good. We need to make an alternative for, in case of error, we need to do something that just affect the client or the customer who wants to buy the pizza with unavailable ingredients, but without affecting any other requests. We want to make sure that this program will never fail in order to keep repeating this action. So we can define a program that will never fail. Let's make like action will never fail with unit. Maybe it would be print line or something, because we will not use the result of that program, but the most important that this fallback action should never fail, because in case of failure, in case if prepare pizza will fail, we want to do, for example, or else fallback action, and this will become a program that will never fail. So you see here the error type is nothing, so this program will never fail. And because we need to have the state, in case if that program prepare pizza failed, it means that the state will not change. We can do .as current state. It's like we will return the current state as a result in case of failure. So we are going to update the available ingredients with the same state, which is fine. But now, for example, if we want to specify the name of the client, because the request contains the name of the client, we say maybe we want to make a computation using that name, and so we can get that name here using request.name. And also maybe the client or the customer is interested to know about the error, which ingredient was missing. We can also have unavailable ingredients. We can tell the client that sorry, there is no more tomatoes. We cannot you cannot have a pizza tonno, so they can change their mind and order another pizza with another ingredient. So we can, to get out the error, we can call catch all, and then we call fallback action of that error and the name, request.name. So, and then also don't forget we return the state, and as is like a map underscore current state, but to make it better. And here is because I'm using the plugin, ZIO plugin in IntelliJ, thanks to Igal for implementing this. So here now it is better, you can see a nicer code. And yeah, now you can imagine this would be something like when we call handle request, it would be something like this: error name, and we can call a program that say sorry name, that uses this name. The problem was ingredients. Oh, sorry. Error. So like it would be something like this, and it's like the fallback action could be a simple UIO with print line, but what if we want to use console, ZIO console, using putStirLine, console.putStirLine, so we can test it if we make sure that the client gets the correct message in a case of failure, for example. And what if we want to interact with another service that will send to the client? What if we want to make a REST call that send to a message to the customer? So we can make it flexible by adding an R here, and also now we also need to make sure that the program now will never fail and has that R. But actually this is wrong, because the schedule, because we use it to repeat schedule spaced, which requires a clock, and duration also requires a clock, and we will not take as a result, we will ignore the result. Like we need to make it as a unit, because this repeat of this schedule will the and will return the tuple of the outputs of both schedules. For the first one, this output would be int, and this output would be duration. So it would be a tuple of int and duration. We can make it a unit because we don't need that result. And also we have to add clock, because we use it that dependency when we repeat that action using the duration and the space. Nice. Now our program is fixed. So the last step is to start how to start the system. We need to make to build the request, and we start the system using the ingredients, given ingredients. We can call start initial ingredients of type map ingredient int, and this would return a UIO of system. So we are going to build the system. It needs requests and ingredients. It needs a queue and ref. So let's make a queue. In ZIO there are different types of queues. There is, for example, bounded queue, and we need always to specify the types of the elements of the queue, and bounded queue requires the capacity. For example, if we have a bounded queue of 3, we will be able to send requests, to add requests, and offer will always return true. But if there are more than 3 requests, in, like, for example, if the queue is full and has 3 requests, the 4th request will, when we call offer the 4th time, this will be suspended until the handler request will take some requests, so we can have a room for the another requests to be added in the queue. So bounded queue will not lose our requests, but it will wait until there is a room for the request. It's like in the restaurant, we can say, okay, we have 12. The capacity of the restaurant is 12. There are 12 tables, and if there are some people want to enter the restaurant, we say, yeah, for sure, you are welcome, but you need to wait until some people will finish their requests. And this makes sense. It sounds a good type for our case. But let's see another types. For example, unbounded. For unbounded queue of requests, it doesn't require to specify any capacity, because it will always accept requests, and the offer will always return true. We can add unlimited requests to the queue, but this will make the restaurant crowded, and we don't want to do this. But it's possible to use it, but actually I wouldn't prefer to use it. If we will make a sliding queue of requests, for example of 3 elements, this will, when we offer 3 elements in the queue, and then the 4th customer will come and add a new request, the oldest customer will be removed and the new customers will be added to the queue, and this is not something nice in our case, so we don't need to use it. And in the case of drop-in queue of request, it's like when we have already 3 customers and there is a 4th customer came, we say, sorry, you cannot enter, the restaurant is full. And we don't want to do this. We actually want to make a welcoming environment, and let's use a bounded queue of requests, and this will accept all the requests, but in case if there is no room for them, we will ask them to wait a little bit until some requests will be performed and will be finished. We'll take their pizza, etc. And let's say we have 12 tables in the restaurant, or 12, and for the available ingredients, let's say we can make a ref of initial ingredients, and this will take we'll make a ref with the initial state. So, and we use them here, and now we have built our system. So when we want to interact with this API, we can call system.start, and we start with initial ingredients, and then we send some requests and handle them, and we will see the result. The next session I will make a test for this example using ZIO test. I hope you enjoyed this session and see you soon.